Excuse me. Wow, just hacked up a glob of spit. Smitty here. I'm going to be working on picking up the project that I worked on last time with the WS2812 ring of LEDs and the ESP8266 microcontroller to control it as a clock. Last week we laid out this circuit board over here, and then I sent it off to Osh Park to be fabricated. Well, guess what showed up in the mail today? So we're going to be trying to assemble some circuit boards today. Lovely purple envelope, my favorite thing to get in the mail. You'll notice that I've got a couple of cameras here. I'm in a different spot than I usually am. My computer is over there, and I've got a couple of these webcams that I'm setting up at my soldering bench, my work table, to hopefully be able to solder, or to be able to stream some of the assembly stuff that I want to do for some of my projects. I've got this camera that's kind of right in my way, unfortunately. It's, you know, this one is going to be shooting down onto my workspace here. The software I use for this is called OBS. It's Open Broadcast System. OBS has a bug. I can't put two cameras into the system at the same time, but what I can do is I can switch back and forth between the cameras. That's all I can do at this point. So, hi, there's a board. That is the camera that's shooting down on my desk, and this is the camera that's facing at me, and unfortunately I cannot do both at the same time. Well, my goal is to have, you know, the picture of me down in the corner over here with the main shot being the overhead shot like that. So unfortunately I'm just going to be able to, I'm only going to be able to do one or the other today, so we're going to have to just make do until I get all this stuff figured out. But the important part is my board showed up. So that's the board. Let me face it the right way. And so we've got the ESP8266 port at the top, and of course the camera's not going to focus this close in. That's unfortunate. We'll figure it out. The ESP8266 at the top, a couple of capacitors. We got the little keyhole in the middle for hanging it on the wall. That's where the 2812 ring goes. Some buttons, connectors, power down at the bottom, a regulator in the middle, and then the three pots on the side that are going to be used for turning this into an analog panel meter clock. How do I get this to focus? So we're trying to figure this out because this is a whole new camera rig for me. You know, still experimenting with some of this stuff. I got to figure out how to get this thing to focus. But the way Osh Park boards come is you'll notice that they have these little. This one is a little thing sticking off the side. The boards are connected, they're panelized, where you have a whole bunch of different boards from other people, and they all get put together in one really big, large panel that they send off for fabrication, and then they route these traces between them, little tunnels between them, and you can kind of see how those go together. Pretend that was a different board. But sometimes you get that little chunk of board in the middle left over, so I just grab my cutters, just snip them off like that, and they typically go flying across the room, which is, you know, fun. Poke an eye out, because that's what our goal is, right? It's all not fun in games until someone pokes out an eye. All right, so we're going to go assemble this board. And yeah, I got to go with some parts. So I'm going to switch camera back to me. There's the board. I need to get some parts. First thing we're going to do, hey look, I've got one on my table already, is a set of female header pins. So this is a female block. These can be cut. So for example, I'm going to use the females on the ESP8266 section, the connector at the top, where it's a 2x4 pin connector up there at the top. So what I'm going to do is I'm going to cut these 4 at a time. The females do not break apart like the males do. When you have male pins like these, I don't know if you'll be able to see it, they're kind of ridged between each one of the pins, and so you can very carefully, with a set of pliers, grab them. Here, I'm gonna, what do we need? We need no, I'm gonna do that one as a female. The only pin headers here, I'm gonna have 3 2s and then a 6 for the FTDI. So we're going to go ahead and do that. You just grab it so that there are 6 pins over here, and you can just kind of go snap, and they break right off, right? And you don't lose any pins because they break right between the pins. You can't do that with the females. The females, when you cut them, you sacrifice a pin. So you have to cut it right in the middle of the pin because there's no kind of ridge between the pins to break them. So let's see, what did I say? 4. I need a couple of 4s. 1, 2, 3, 4. So I'm going to go to the 5th one, put the cutters right on top of the 5th pin, and then cut right through. And now I have 4 pins left, but I also have kind of half of the 5th pin hole there. I don't know how well these are showing up. Add a little bit of better light there. Anyway, so it sacrifices a pin every time you cut a female header, which is a bit of a bummer, but they're cheap. It's not that big of a deal. So I've got another 4 there, and then they are sized correctly. Here, let me go to the other overhead. They are sized correctly so that when you put 2 of them next to each other, like that they ride nicely. They will fit nicely next to each other like that. And then if you want, you can go in and clean up the little extra bits on the side with your cutters so that they don't stick out. You're cutting off that other pin that you sacrificed, cutting off the plastic that normally surrounded that other pin that you had to sacrifice to get there. Do that on that one. Just kind of cutting off the extra bits on the side so that they don't stick out any farther than they need to. All right, so now I've got a 2x4 female pin header without having to actually differentiate between the 2x headers or the 1x headers. I'm used a couple of 1x headers to make a 2x header, so that worked out pretty well. There's no reason for that not to be the first thing I'm going to solder, so let's go ahead and really throw stuff all over the place. Where'd it go? There it is. So first thing you'll note about my workbench is that it is incredibly messy. Anyone who tells you that they keep their workbench clean is either lying or a sick mind. I'm sure there are people out there that keep their workbenches clean, but I am not one of them. Yeah, I am totally experimenting with this overhead camera thing. This may or may not work out. We'll find out. So I'm going to go to the bottom side. Let's see if I can get this a little closer. I'm going to go to the bottom side of the board, and I'm going to hold a connector in from the other side. Normally I do this differently. Come on. But yeah, I'm actually not sure how I'm going to do this. So come in with the solder, kind of hold it in with one finger. You only need to do 1 pin this way, just enough to hold it in place. Just enough to hold it in place, and we can straighten it out later. Let's go ahead and get the other one in while we're at it. Come on. Okay, so now I have held the connectors in. Oh, they're pretty straight. So one of the things you want to do is you want to make sure that they are not leaning over. You want to make sure that they are straight and, well, perpendicular to the board. That they're not kind of, you know, off at an angle here. You know, you want them straight up and down perpendicular to the board. And those look like they're pretty good, actually. So I'm going to go ahead and solder the 6 remaining pins on those. Is that working out okay visually? So there are a lot of YouTube videos out there about how to solder, and I've even done some myself. I'm not going to bother doing a how to solder video here because there's a lot of that, and I think we'd spend a lot of time on that if we wanted to, but I don't want to right now. I'm going to concentrate. I'm going to assume you know how to solder. If you don't know how to solder, then I refer you to plenty of other video tutorials on how to solder. Okay, well, while I'm on this side, let's go ahead and put those capacitors in. So, oops, actually that's not what I wanted to do. Forgive me. We were talking about stuff in the workbench. Over there is a shelving unit I have with a bunch of parts. I buy in bulk. When I go to eBay or Mauser or whatever, if I need 1 or 2 parts for a thing, I will buy 10, depending on the price break point, sometimes 100. For example, right here are my electrolytic capacitors. I have an entire bin dedicated to electrolytics. I just found them earlier, so I know that they happen to be on top, but these are my 47 microfarad 25 volt or 35 volt electrolytic capacitors. So when I do a circuit like this, I just know that I have a bunch of these. I bought, looks like 100 of them, because they were dirt cheap and they're convenient to have on hand. I'm going to need 2 of them. So I come in, just cut one off, cut the second one off, oops, almost drop them. There are my electrolytic capacitors. Put them down on the table, shove this back in the envelope. Boom, done. And I've got lots of other values of electrolytic capacitors in there. I've also got my ceramics in microfarads. Most of these are chip capacitors, 1206s. I tend to work in 1206s, not in 805s. Here are my chip capacitors in picofarads, just kind of a convenient way to separate those. So on and so forth. Lots of different values over here. I've got my voltage regulators, op amps, connectors and sockets, transistors, diodes, infrared stuff, headers, lots of headers, 0.1 headers. There are a lot of different things in there. When I pointed out the the 0.1 pin headers and the male and the female, I've got all kinds of different things in here. You can get the males in packages of 50 at a time, 100 at a time, and they're dirt cheap. They're good to have on hand. I got some right angles in here. These are the female pins that go into, that you crimp on the end of a wire and put in connector headers like these, right? So I just have these in bulk because just about any project you do is going to have that kind of connector on it. Similarly, down here, I got my bulk kind of low precision resistors. They're not really organized. I have to go searching through them every time I want to use them. But otherwise, for my high precision stuff, I got my trim pots, less than 1 k ohm, meg ohm, a bunch of heat sinks, stuff like that. I've got modules and things all over the place. Here are where my RF modules are. So I bought a bunch of, like here's a ESP8266. I got some NRF 24s, the on-off keying kinds of things. I kind of regret buying this many of them because I intended to use these as a way of distributing serial NMEA data around my house. I have one GPS in the office that would output an NMEA string and then just put a bunch of receivers on different things around the house that needed NMEA data. And that didn't work out. It just completely obliterated my my weather station, which also used the same stuff. Anyway, you get the idea. Lots of different things over there, and that's where I'm going to be pulling a lot of my values for. So, for example, ooh, that's a new sticker. All right, Osh Park. That's a new one. I'm guessing the 9th one. I got to go make sure I can collect all of the others. Anyway, electrolytics. We all know that electrolytics are polarized. I got a negative on that side and nothing on that side, which means it's positive. So you need to make sure that they go in correctly. Oh, shoot. I usually put a plus on the board. I didn't this time. But the white side of the outline is the negative side. And I can tell that because the positive side, the non-white side, has a tie to this plane here, which is a power plane. And if you look on the bottom, there's a thermal tie, and it's not going to show up because this thing doesn't, it's not going to focus that closely. Trust me on this one, the white is the negative. So I'm going to stick that in and bend those out a bit. Stick that one in, observing the orientation so that the negative side, the white stripe, goes on the white side of the outline. And let's solder these in. Again, I'm going to do one side, make sure the component is up against the board flush and oriented properly, And then I will do the other side. It's a lot easier to move it around when you've only got one wire done. You only have to heat one up to make it orient correctly. All right. Yep, that looks good. Blast. Trim off some leads. They go flying, which is part of the way that my office gets to be a mess. All right, what else? What's next? Well, let's see here. I'm probably going to have male pins on the ring, so I want some females here. Let me go ahead and make another 3x female header here. So 1, 2, 3, cut on 4. There's a 3-pin. Okay, that's what I want. Trim that up. Slide it in here. Oh, but I gotta solder it from the other side. That looks straight to me. I don't know how well you can see it with this lighting, but that looks pretty good to me. Unfortunately, this is all very out of focus. The camera doesn't want to focus this close. If anybody knows how to do that properly, or has a suggestion for a better camera, this is a Logitech 920. If you have any suggestions on how to do this better, let me know. This is the same camera that I use. It's my personal camera that I usually use at my desk. I moved it over to my workstation here. Okie dokie. That. All right. Let's get that voltage regulator in there. Again, I have a bin over here for voltage regulators. Gotta find it. Nope, that's not it. There it is. Oh, that's a 5 volt. I think these are the 3s. One other thing, if you don't have, is get one of these magnifiers with a light on it. They are pretty awesome. I don't know if you can see a part number on there, not through the plastic. This whole thing is going to be an experiment to see how well this stuff translates to video. But yeah, it's not going to show up well. Anyway, trust me, this is a 3.3 volt voltage regulator. Right, I only need one of these, so I'm going to take this out, put it on the table. When you take these out, always face them down so that they don't go flying. You'd rather it drop than fly. Okay. Surface mount. Surface mount is fun. Surface mount has kind of a scary reputation, but it's really not that bad. So the way you want to do surface mount is you're going to pick one pin, one lead. Doesn't matter which one. I'm going to go ahead and pick that one because that's the side where my soldering iron is. I'm going to put some solder on that one lead. Then I'm going to use my tweezers, pick up the component. If the component's big enough like this one is, you can usually do this with your fingers. You don't need tweezers, but for the little components you want to use tweezers. And I'm just going to put it in place and heat up that solder blob and get that one pin soldered. Now that one pin is soldered and it is holding the component in place. God, why won't it focus? There is nothing beyond this. Why are you not focusing that level? There we go. Anyway, I got to get a better camera. And then you go in and do another pin on the opposite side. And now you've got good, holding it in place from all from multiple corners of the board. I'm going to go back and redo that one a little bit. And then this one's going to take a little bit extra heat, but not much because it's not that big of a heatsink tab. And boom, surface mount component is in place. It is helpful to have a nice fine tip on your soldering iron. This is a Metcal. I love my Metcal. Let me go on and on and on about how much I love my Metcal. But I got a nice fine tip on this one, and it works out well. Okay, let's get, you know what, actually I want to put the buttons in first because the buttons are lower profile than the header. So I'm talking about the reset button and the program button. They are a lower profile than the FTDI header. And you want to put your lower profile components in first, just because it's kind of a pain in the butt to put them in when you've got a lot of high, tall components near them. So I've got a bin full of buttons, right? Got a bag full of, I think it's like 200 or 500 of these little 2-pin buttons. Lots of, you know, the common 4-pin buttons that you can get on eBay. I buy them hundreds at a time because I'm going to have lots of different projects that use these things. And rather than buy just enough and then have to wait 2 weeks for them to get here, 2 to 4 weeks for them to get here from China, just buy them in bulk. They're not that expensive. And then you have them on hand. And then the next time you go to design a project, you have the part already. You know how to lay it out, what component it is, and how it works, and all that fun stuff. You start standardizing on certain components. All right, these leads are already kind of curled, so they already hold themselves into the board. Luckily, I don't have to do any pin bending to get these in place. Okay. A little bit of a hint, a little bit of a cheat. Whenever I give a soldering class, I always tell students that you put the soldering iron on the pad and the pin, and heat them up, and then let them melt the solder. I always tell students not to put solder on the tip directly. I mean, it doesn't hurt the tip, it's just not going to give you a good solder joint. I have a confession to make. That's a bit of a lie, because that's not how I solder. Let me put the 6-pin header in here and I'll show you what I mean. So the way I do it is I will start getting, oh, by the way, when you're holding these in, make sure you hold them in by some pins. Make sure you don't hold it by the pin that you're going to be soldering, because those pins are not very thermally large and they will start getting hot very quickly. Okay, so what I do is I start getting that heated up, but I will touch a little bit of solder directly to the iron and then make sure that that touches the pad and the wire. And then having that solder on the iron touching the pad and the pin, it flows and it creates much more surface area for the heat to transfer from the soldering tip to the pad and the pin. So I will usually put just a little dab of solder in there first to help the heat flow from the iron to the pad and the pin. A little trick that I usually don't tell new solderers, because the whole point is to make sure that the pad and the pin are hot enough that the solder flows. And usually new solderers don't make it hot enough, and they just put a bunch of solder on the iron tip, and then you just get this giant bubble of solder on top of your solder joint, which is definitely not what you want. Okay, that's coming together. 2.1 millimeter, there it is. Yet another bin full of parts. I have a lot of 2.1 millimeter connectors. Here's a bag of the board mount ones, just like that, standard 3-pin, same one that everybody uses. I got some that are meant to go on the end of a cable, some that are meant to go on a like on a chassis mount, that kind of stuff. But these are board mount. Is that going to hold it in? It's not. Okay. Okay. That was a little tweaked. All right, good enough. And you see I'm pushing on the bottom of the board while I melt the solder to make sure that the thing is flush with the board. These big holes take a lot of solder. Okay. I could probably do to trim those off at the bottom when I'm done. But otherwise, that board looks pretty much done for the WS2812 side of it. I still got these parts over here for the analog. Yeah, we'll go ahead and do those since we're here. All right. 10-turn trimmer pots. Again, another bin full of trimmer pots. You can get them, you know, a bag of 20 of them or 50 of them or whatever it was when I first bought it. I use these a lot. Anytime you need some precision adjustment. So I don't know if it's going to show the 103 on the top of that is the same as any resistor code. It's really not. 103 means 10 or 10 times 10 to the 3 times 1,000. So that's a 10K pot. Is that going to show up? There you go. 103. So that means that's a 10K pot, and I need 3 of them. All of the ones in this bag were 10Ks. You can also get, you know, sample packs where there's like 10 of each of a bunch of different values. I got a couple of those. You know, like I said, buy in bulk. They're not that expensive, and you will have them whenever you need them. And there are certain components that you will use a lot of. Okay, put that in. So, if you remember correctly from the last time we talked about it, I did a episode of Know-How, or it might have been Coding 101. I honestly don't remember which one it was, but I did a podcast with Padre SJ, Father Robert Ballitzer, where I talked about an analog panel meter clock. And in fact, it's right up there on the shelf. I'll show it to you later. Basically what you do is you use the microcontroller and the pulse width modulation, the PWM output on the microcontroller, to output an analog voltage through a resistor to get the right amount of current to flow through your meter. And then in that way, the microcontroller can control where the meter is in its throw. And you can use it to output just about any information you want. And so that's what we're doing here. The trimmer pots as resistors will allow us to adjust how much current gets sent for a given PWM value, because not all meters are the same. Most meters that I try to go for are about 1 milliamp. 1 milliamp for full swing. If you have a meter that is, those look straight, right? Yeah, that looks pretty straight. I'm going to call that straight enough. If you have meters that are voltmeters, really all they are is a current meter with a resistor in series so that a given voltage will pass the correct amount of current. The meters themselves don't work on voltages, they work on currents. It's just a little electromagnet. The electromagnet doesn't care about the voltage, it cares about the current. The current is what creates the magnetic field. Now, the coil itself has an impedance, has a resistance in it, and so you have a certain amount of current that you need to send through across that amount of resistance. That will turn into a voltage. So it's not quite fair to say that the voltage is variable, but it's the current that matters. And so if you want to make a meter go for a different voltage range, you can adjust the resistance so that the right amount of current goes through. The current is ultimately what matters. Okie dokie. And 3 more, those little 2-pin headers. So I've got a male there and I've got a male there. I'd rather use the shorter one. Where are my pliers? They're there. So I'm just going to grab 2 pins from the end there and just kind of snap them off. Just bend them off like that. You do that 3 times and you end up with 3 2-pin jumpers. Or not jumpers, but headers. And then we come in and solder these. Okay, these are going to be too hard to do the other way, so I'm going to show you the other way I kind of cheat on these. I usually do this off the edge of the workbench here, hang the solder off the edge here, but this will work as well, and it'll be easier for you to see with the camera. So I'm going to put the header in, I'm sorry, you can't see that. I'm going to put the header in here. I'm going to hold it on the back side with my finger. So notice that I'm using my fingernail on the plastic. I'm not touching the pins, because if I touch those pins, I will burn my fingers as I solder the other side. So I'm holding the thing in with my fingernail, but I don't have a third hand, so I'm just going to position the solder so that I can go in like this. Okay. That'll hold the first one in place. Keep it flush. Ow. Like I said, what do you know? Thermodynamics, it works. Come on. Darn it. It's a problem with putting these so close to the resistors, to the pots. There we go. Same thing. Hey, hey, get over here. This is not being cooperative. Okay. If I were trying to hold these in with my fingers, I would be burning my fingers right now. So that's why I do it with my fingernail instead. The other advantage to holding it in with the fingernail is that you can be pretty darn sure that it will go flush up against the board. Okay. All 3 of the headers are connected, or at least one pin of the 2 is connected. Now we put it in here. And we will solder the other 2. Whoops, a little too close. The other side. It's done. What do you know? Look at that. So I have an ESP8266 that I have not yet programmed, but that's what the 8266 looks like, or at least the ESP8266-1 or -01. Come on, focus. All right, my camera is not cooperating with me. You're going to have to go look it up yourself. But we hang that up off the top like that, so it kind of sticks out the top of the board, which makes the antenna in the free and clear. And let's go put some right angle pins on that clock ring. Careful. So this is what I had on it before. I had the pins come off parallel to the ring itself. What I'm going to want to do is replace that connector with one that sticks out at a right angle. So luckily I have some right angle pins. Let me go get those. They are in my .01 headers bin. This is the bubble wrap they came in originally. There's the short one. See how they're at a right angle? We're going to grab 3 of them. Kind of hard to see, but okay. Just going to pretend that joke didn't happen. All right, so we got to remove the connector that's there. Let's see here. Scoot that over. Scoot all of that over. Solder wick. One of my favorite tools. Solder wick is literally a weave of copper that has some flux on it. And what you can do you can come in, put this on top of where you want to remove some solder. You put it on top of and then heat the wick with your iron. And what it does is it goes in and heats up all of the solder and literally wicks it away. And it works really well. It doesn't usually get the very last little bit of solder, but it gets enough. Oh, well, I'm destroying this connector, but that's okay. See above, I've got lots of pin headers. I can replace it. Especially since this is the one that I want to replace with the right pin, right angle. Oh, man, I really munched that one up, didn't I? Okay, there we go. So notice how the solder wick pulled up a lot of the solder that was there and made it a much easier process to try and remove the component. Okie dokie, that's trash. We are going to, I don't know if you can see this on the camera, but I'm going to put that there. I'm going to need to move these out to the side a little bit. Because I want this to be pretty close to centered on that. This, unfortunately, is something that I may or may not be able to show very well on the camera because it's going to be close in and my fingers are going to be in the way. Okay, I'm going to hurt myself. Ow, 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 ow. You know what? I lied. Ow, ow. Okay, never mind. Shoot. My ring is off center now. I mean, there's a little bit of a ledge on that. See if I can get this to focus. Notice how they're a little offset now? Blast. All the other corners, all the other joints look pretty good. I really wish I knew how to get this camera to focus. There we go. And then the fourth one, that one's a little bit off, but not too bad. This one is where you inject the data. So you'll notice that all the other ones, the in and out, were connected, but this one was not, because the in here is where you start, and the out, oh shoot, the out is where you would send it if you wanted to do more out after the ring. Ah. All right, I'm going to start over with this. All right. But I need to be careful not to connect the in and the out on this one, because that would be bad. That would do bad things. So, ow, 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 ow. Ouch. Bloody hell. That was hot. All right. So I've got the connector soldered on to one side. I'm going to put the other ones in, as in the VCC pin is soldered. The in and the ground are not yet. I'm going to put those in now so that this will be structurally sound. Then I'll redo the VCC so that it's good. All right. Now technically, all right, so that's still disconnected, which means that I am not bridging the in and the out. But I do need to connect the VCC and the ground now. So where were those wires that I just took off? Tweezers, one of my other favorite tools when working on these kinds of things, because I've got big sausage fingers. But I'm going to put that in there. Okay. I think I got that one. All right. Can't find the other one, so I'm just going to have to make another one. Just a little lead clipping. Unfortunately, this is not going to show up very well on the camera, so I apologize ahead of time. Here. Just put a little bit of a bend in it so that it can go on the outside of the pin over here, but then connect in to the board on the other side. Technically speaking, this connection isn't necessary because power and ground will get around to that side of the board all the way around the ring. But doing it this way means that it'll have a better even distribution of power, and more importantly, I wanted something for structural, to hold it structurally together. Okay. That looks pretty good, and I've got the thing right in the center, although it probably should have been directly over one of the LEDs. Oh, yeah, okay. In any case, this is going to connect onto the board like that, and then, look, it's a clock. That's the idea, and that we're going to hang it from the wall from a drywall screw. Look at that. And then we can actually like screw it into the wall if we need to, and that will kind of keep it flush. But that's what it's going to look like. What do you think? Think it'll work? Let's find out. Okay. I did not put a 5-volt regulator on here, which means that I need to make sure that I use a 5-volt wall wart. And I think I put the 5-volt source away. Let me go get one. Yet another of the big boxes of things on my shelf. I collect wall warts. Whenever I throw away a device that has a wall wart in it, I pull the wall wart out and make sure I've got it. 5-volt, oops, wrong one. 5-volt, 2 amp. That will do swimmingly. 2.5 amp. That is way overkill. 9-volt. 5-volt, 2.6 amp. It's even more overkill. All right, I'm going to stick with this one for now, just for testing. I will probably find a more appropriate power supply later. The other option is that I could have instead of putting the 2.5 millimeter barrel plug on there, I probably could have put a USB micro, like a micro USB connector on there, or even just a USB-B. I didn't. I don't know why. Probably should have, actually. USB is a much more common power source these days, I guess. So I want to take all of the active electronics off the board before we power it up, because if I screwed something up, I don't want to destroy my components. All the passives that are on there, if they get destroyed, I'm not too worried about it, but I don't want to destroy any of my actives. So, I think I'll let out the magic smoke. It's connected. Usually the first thing I do is I touch the regulator to see if it's passing a whole bunch of current. Nothing is warm. Sounds pretty good to me. And unfortunately, my fingers are so calloused, it's hard to tell. Turn on my voltmeter. Put it on that scale. Come over here and let's measure some voltages. See what we got. I didn't put any test points on here. I probably should have done that. Here, let's go back to the overhead, make this a little bit easier. Oh, gut shot. Sorry about that. Nobody wants to see that. So, I'm going to go ahead and use that as my negative source. That should be my positive. And I do not have a camera on my instruments. Okay, that's 5.2 volts. That should be 3.3 volts, 3.28. That's good. Let's measure across the ring. That should be 5.2. I've got my leads backwards, but that's 5.2. And then power on the ESP8266. Maybe it's those. Why are you not measuring power? Let's measure it on the capacitors then. .28 there. Okay. Oh. So one of the problems about using flux core solder is that it leaves behind a residue, which sometimes breaks this kind of testing. It's not made any easier by the fact that I don't remember which pins are which. I know VCC and ground are opposite corners like this. Here. There's a ground, so I only have to worry about what? .9. There it is. Okay, there we go. Yeah, I just had to get through the rosin. So if I plug this in, we should see some light. Hey, look at that. It lit up. Now this ESP8266 is not yet programmed. So let me go get one that is. Hold on. I will be right back. So I think I've got two that have been programmed. This is the first one that I started playing with, that I have the capacitor hanging off the top side. And then this is the one that I put on my, remember the proto board that I made the other day? This is the one from the proto board. So if I plug that in there, plug that in there, in theory, this should turn into a clock. Why do you think it's that time of day? Turn off the overhead lights. Why are you in dim mode? There we go. You just needed to get your time. So this is telling me that it is 2:35, 2:37 now, I guess. 2:37, look at that. What do you know? It works! Crazy talk. The next thing to do is to test the FTDI serial programming header, and then I need to work on some PWM code. Apparently, I started writing some code, the pulse width modulation library, because it's all software pulse width modulation on this thing. It doesn't have a hardware PWM, or at least not one that's exposed on this module. So to do PWM requires some interrupt timing on that thing, but I think the library that does the WS2812 writing uses the same timer. And so when this thing is going, I can't do pulse width modulation on these at the same time. Or there's something going on underneath the hood there. I'm not sure entirely what. But that looks pretty cool. I think it works. What do you think? My clock. I want to thank John Fuge, or F-U-G-E. Again, I haven't figured out how to pronounce your name. I'm sorry. I want to thank John for writing the code for this and coming up with the idea, putting together everything on the Instructable. The link for that is down below in the show notes. I want to thank Osh Park, because my previous episode on this subject got retweeted by them, and the ESP8266 community saw it and started retweeting it. The folks on the Amp Hour retweeted it. It got posted in their Reddit group. It has been my most viewed video so far, and that makes me feel good. Thank you, everyone. I really appreciate that. I'm happy to see that it worked. This is not scripted. I literally opened the envelope on this stream and got these boards out and have assembled one. It makes me super happy to see that these things are working. What I want to know about is what you're working on. I am at Smitty Halibut on Twitter. Grab a hold of me, at me, DM me if it's private, whatever. Let me know what you're doing. Let me know what you're working on. Show me your success stories. I want to see pictures. I want to see movies. I want to hear stories about, I ran into this problem, but I had to do this to overcome it. It was kind of a pain in the butt, but I fixed it at the end. Or your war stories of, I am stuck on this thing and I can't figure out how to do it. Do you have any ideas? I don't care what it is. Come talk to me. Tell me about what you're doing. Tell me about the awesome things that you're creating, or the ideas that you have that you may or may not know how to create yet. That's what this is all about, right? I want to come up with an idea. I say, I have a problem that I want to solve. I don't necessarily know how to solve it yet, so let's go figure that out and put it together and make something that works and make something that's awesome. That's what the whole maker philosophy is about. So tell me about what you're doing. You can do it down below in the comments, but really the best place to get a hold of me is on Twitter. Like I said, at Smitty Halibut. Thanks again to everyone over at Osh Park and the Amp Hour and the ESP8266 community for retweeting me and letting folks know about this. It works, so I'm super happy about that. Thank you guys for watching, guys and gals. Thank you everybody for watching. Let me know how things are going and what you're up to. Thanks, and we'll catch up with you next time. This has been Smitty Halibut working on something. Have a great day. And then I'm going to go do that. All right, cheers.